Good morning, class.
You say hi, Sammy.
Hi, Sammy.
Join Sophia.
I'm Sophia.
Okay, out of here. Hey, peeps. So today is get out of here. Seriously. Today is Thursday. You should be watching this on Thursday. So there was a little bit of mix-up. I did go to school this morning. Technically, it's Wednesday, is when I'm recording this, but and you know, I gave my doctor's note, and I was like all excited to be back at work, you know, and they put the wrong date, so it says next week. So stop. So I'll have to get the doctor's note done, and hopefully I can come back on Friday, but we'll see. Okay, I do want you to just write quickly down so that way you can make sure that you're on track, because you guys know me, I'm going to be really upset if I have to come back and do 50 million things with you. Okay, so by now, as of Thursday, you should have completed, since I've gone, the bundle, assignment 10. Okay, so today, write these down, these just assignment number 10, whatever, and go through and check and make sure that you've submitted them on Canvas. Or in the box, whatever, okay? So, assignment 10, the bundle, that one should have been submitted through Canvas. Assignment 11, okay, Pythagorean theorem day 2, you would have done that on paper, so make sure that you have that one done and turned in. And then today we're going to be doing assignment 12, the hypotenuse leg theorem, okay? So, if I come back on Friday or tomorrow, those are the 3 things that you should have done, completed, submitted on Canvas, or in the box, and I'm going to be very upset if you don't. So, if for some reason, because there was a mix-up with some subs yesterday, if you've already completed assignment 12, that's totally fine. Then use that time to make up any missing work or sleep or whatever. I don't really care. Just don't be a disruption, okay? But if you haven't, then you're just going to continue watching the video and do that assignment today. I miss you guys all very much. My leg is healing very nicely. I crutched my way in the ice and everything this morning, and only to find out that it said the 10th on it instead of this week. I was so excited, like, oh, here's my note, and it was the wrong date. Remember, I told you it's against the law for them to let me come back before the date. So, you know. So today we're going to do the hypotenuse leg theorem. Hopefully most of you guys get the swing of it. It might be a little bit rough since it's day 1. We're not going to spend too much time on this. The worksheet's going to look a little bit different than what it normally would. Okay, but there's a theorem called the hypotenuse leg theorem. Okay, and we've already been exploring this, and it goes in hand with the Pythagorean theorem. Okay, so we have a hypotenuse, which is always going to be the longest side. Okay, and it's across from the right angle. Okay, and then there's always going to be legs. Okay, and so you can prove that 2 triangles are congruent with no numbers, because before we had this Pythagorean theorem, and you could say a squared plus b squared equals c squared. Yes, it's a right triangle, and if they were both the same numbers, you knew that they were congruent. Okay, but if you're given something like this with no numbers, there are ways to prove that it is congruent through that hypotenuse leg theorem. Okay, but the verbiage and those key concepts are very important. So remember how we had side, angle, side? And that angle had to lay in between those sides. And so this works the same. So it says if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of the other right triangle, then the triangles are congruent. So what that's saying is on each of these 2 separate triangles, you need a right angle, okay? Okay, you need a hypotenuse, and they need to be congruent. And the hypotenuse is always the longest side, and it's the one across from the right angle. Okay, and then we need another leg that has to be congruent. So, these 2 could work, or you could use this bottom side, that QR and that YZ. You could put, and in this case, it would have to be marked with a 3. 1, 2, 3, 1, 2, 3. Okay, so if you didn't have that blue one, that XZ or that PQ, that would be fine. Okay, you need a right angle, a congruent hypotenuse, and another side, another leg to be congruent. Okay, so we need a right angle, check, got it. Okay, I'm trying to write on the dang TV. So you know I've been home too long. Okay, we need a right angle for both of these. We need, on the opposite, the hypotenuse, they have to be congruent, and then one other angles need to be congruent. Okay, and so those are the three things that make that hypotenuse leg theorem true. And it's kind of in the title, hypotenuse, which includes that right angle and those hypotenuse, and those legs. Okay, so same thing with the conditions. It says there are two right angles, okay, one for each triangle. The two triangles have a congruent hypotenuse, and there is at least one pair of legs that are congruent. Okay, so number one, it says for two triangles to be congruent by the hypotenuse leg theorem, there must be a, it's going to say pair of right angles, pair, and I'm writing on the iPad, so don't say nothing, of right angles, Sky, place, and the lengths of the hypotenuses and one of the legs of each triangle must be equal. And we'll say one of the legs of each triangle must be equal. Okay, and I'll scroll this out a little bit so you can take some time to write. Lord knows Bree writes slow. Bree, take a picture. Okay, so for the two triangles to be congruent by the hypotenuse leg theorem, there must be a pair of right angles, and the legs, or the lengths of the hypotenuse, and one of the legs of each triangle must be equal. So what that's saying, again, so if we drew a picture, and mine don't look the same size, but they secretively are. Okay, we need a right angle. The hypotenuses have to be congruent. And either one of the legs need to be congruent. So you could draw this one with two tick marks and this one with two tick marks, or you could do this side with two tick marks, this side with two tick marks. Okay, so, and I'll do the bottom side. It's a crappy color of blue, so you can't hardly see it, but it's there. Okay, so take a second. If you guys are still writing, then have the sub pause it or something. Okay, look at number 2. Okay, it says, for what values of x or x and y, okay, are the triangles congruent by the hypotenuse leg theorem? So the hypotenuse leg theorem tells us that we need 2 congruent right angles, 2 congruent sides, and 2 congruent hypotenuses. Hey, knock it off. Sorry, it's nuts here, but so we have 2 right angles, we have 2 sides. So if this one is 17, what should the other one have to be in order for us to do that hypotenuse leg theorem? Okay, and it's got to be 17. Sky, stop. No. Stop. Okay, so that one's got to be 17. Okay, look at 4. Okay, 4 through 9, okay, it wants us to write a congruent statement for each pair of triangles. If the triangle cannot be proven congruent, write not enough information. So NA, okay? So it's either yes, no, or NA, but you need to tell me a little bit of why, okay? Don't just, so, she's fine. So if we look at 4, okay, with the hypotenuse leg theorem, we need to see if there's enough information. Now, the rules still apply when we had side, 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 angle, side, angle. Okay, if the 2 triangles are touching, you know that you could mark something. Okay, so I will ask you, are these 2 triangles touching? Well, yes. Okay, and so we know that we can mark something for sure. And so we can mark for sure that inside segment. Okay, so we can mark that one with a 2. Now, it's just given that if this one is a right angle, then the one right next to it also has to be a right angle. Okay? So, I will ask you, is there enough information? We need 3 things in order to use that HL theorem, that hypotenuse leg theorem. We need 2 right angles. Check, we got it. We need congruent hypotenuses. Do we have that? Okay, which tick marks are going to be the hypotenuses? Is it going to be tick marks 1 or 2? Okay, if you said 1, you're right. Okay, it's always the one across from the right angle. And so, yes, we got that. And then one of the legs is also marked. So, yes, we can prove this by that hypotenuse leg theorem. Okay, and so what I would like you guys to do is mark me something or something so I can see that you know what you're doing. Okay?